All right, class. So I'm having a little computer issues before I make this. And so I'm on a teeny tiny Chromebook. So we'll see how this video turns out. Or if I'll be headed to the school, borrow a computer. Okay, this video is going to cover 5.2. So I'm going to have to switch cameras so you won't see me. You'll just see what I write. This section is 5.2. Let me get that to be a little more clear. 5.2. All right. That should be pretty good. And this is systems of linear inequalities with two variables. So we're basically going to have two inequalities. So there's going to be a system of linear inequalities. I was trying to remember if we only did linear, which means a line, which we do for this section. So system of linear, where the solution is where both of them are shaded. Okay, so we have done system of inequalities in math 1400 or college algebra before this course, but we actually do a lot more of this idea in this class, so it is important to review this. Our first type problem might look like x plus y is greater than or equal to 6. I'm actually going to turn this. Right. Okay. So we're going to have x plus y is greater than or equal to 6, and 2x minus y is greater than 0. And so here's our two equations, and we're going to graph each one separately. So for this top one, what we're going to want to do is solve for y first, and that will help us with knowing if it's greater than or less than and seeing the slope to graph it using the slope and the y-intercept. If you graph it using a chart and points, you can do that. It's just hard because if you have a negative in front of the y like this, if you solve, it actually switches the symbol and it makes the shading a little bit harder. So I'm going to take this top equation and I'm going to subtract the x over, so it'll become y is greater than or equal to 6 minus x. So that's this one over here, and it's solved for y. Now, the slope is always the one in front of the x. We could rewrite this as y is greater than or equal to negative x plus 6. That's fine also, if you need to have the x first in the mx plus b format. Okay, for this one, when we go to solve this one, we're going to minus that 2x over. So we're going to have negative y is greater than 0 minus 2x is just negative 2x. You don't actually have to write the 0. And then from here, we still have a negative y. So to get that to be a positive y, we would divide both sides by negative 1. But when we do that, it switches our inequality so that this one is going to become positive y is less than positive 2x, like that. Okay? All right, so then from here, we're going to have these two equations and we're going to graph them and then find their shaded regions. So I'm going to get out my little ruler just to make it a little prettier. So let's look at that top one. This 6 represents where we cross our y-axis. So this is our y. So we're going to go 1, 2, 3, 4, 5, 6. There's the point 0, 6 or the y-intercept. Then the slope is negative 1. Okay, if our slope is negative 1, I'm gonna, oh nope, it won't let me do that. So if the slope is negative 1 here, then we would go in one negative direction. So I always teach to go down 1 and then over 1, and then you could go down and over another one, however you want, but that's going to be our line. Before I draw it, it is going to be solid because you have the greater than or less than. So I'm going to draw that line solid. And then I have to decide if I'm shading above or below this Y spot. So this says greater. That means you need to go to this Y, and greater would be including this top part. So it has to be this side. I don't want to shade it all together. What I want to do is use little arrows. And if I had two colors, that would work as well, because our solution isn't where it's shaded, it's where both are shaded. So this will show us where this one's shaded. Now let's go ahead and graph this one. So this is like plus 0. So the y-intercept is at 0, and the slope is 2 or 2 over 1. So we'd go up 2 over 1, and they're both positive, so we go up and over. And then when we go to draw this line, we need to look back. Does it have the equal part? No. So then we need to make sure when we draw this, we draw it as a dotted line. Okay, and I made it really far across my graph just to show. Now this one is less than, so I go to the Y, and it has to, the side has to include this line here. So less than is going to be pointed this direction. Okay, so I'm going to do the little arrows. All right, so if we look, they cross here. That's our solution to sum that we've done before. If they don't have greater than or equal, that's just our solution where they cross. But for the inequality, it's like you have 4 sections, and which section has both arrows? It's this section, because this one up here only has 1 arrow, right? This one has none, and this one has 1. So our answer when we shade will be this entire section. And if you're on the line and the line is solid, then that's going to be okay. If the line is dotted, then you can't be actually on that line, but you could be right next to it, okay? So just remember what those mean. There you go. There's our first example. Another way to check these 4 areas is using a test point. And that's kind of the way the book uses. I like just shading, use some arrows, but the test point would be like, all right, what's a point over here in this section? Well, we could do like over 7 up 0 or something over here. So we could test the point 7, 0 and put that into both original formulas. So the first original one, can't get to show, there we go, is going to be x plus y is greater than or equal to 6. So x is 7, so we'll have 7 plus 0. 7 plus 0 is greater than or equal to 6. So is 7 greater than 6? Yes. So that one worked. And then the second one was 2 times x, which x is 7, minus y, which y is 0, is greater than 0. So 2 times 7 is 14 minus 0. Is that greater than 0? So this is basically 14. And yes. So we did get a yes on both, so this answer is correct. So you can use a test point to check as well. Okay, so if you're asked, like, is this a solution? You do exactly what I just did. You just put them into the formulas, and it's either a yes or a no. So we could have an unbounded region like we do here. Unbounded means it just goes on that way forever, right? It's going to keep going that way forever. Bounded would be something like this is a bounded region. So this one has 3 lines, and you can see where I have the 3 lines, and I have graphed them just like we did, and it is a bounded little triangle region. So you could have bounded and unbounded regions. Let's skip to a word problem that has 3. So then we're going to have one that has not just 2, but 3, and it also is a word problem. Okay, so
A dietitian in a hospital is to arrange a special diet for 2 foods. I'm going to see if I can focus that a little better. Each ounce of food M contains 15 units of calcium, 4 units of iron, and 4 units of vitamin A. Each ounce of food N contains 4 units of calcium, 4 units of iron, and 16 units of vitamin A. The minimum requirements in each diet is 175 of calcium, blah, 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 of each one. Okay, so how are we going to set this up? So what I want you to think of is I have calcium, I have iron, I have vitamin A. Those are like my 3 things that I am talking about. And then I have food M. I should write this a little higher, excuse me. Food M. And I have food N. M, N, right? Yeah, okay. And if I draw this as kind of a little chart, like this is going to have our minimum requirement. Okay, minimum requirement over here. And if we think about this first food, it said it had 16 units of calcium, 4 units of iron, and 4 units of vitamin A. The second food had 4, 4, and 16, right? 16 of vitamin A. And then our minimum requirements were 176. I think I said 5, but it is a 6 on there. Kind of hard to tell. It didn't print real well, so then it doesn't show through on my camera real well either. So then 56 here and 80 here. So minimum requirements. So what I can do is I can set this up with what are the things I need, the requirements here, and each food item in the middle, or whatever it's talking about. It could be, I think the other one was like hours that you worked in on different things in a company. So then from here, I can write my formula. What does it mean if you say minimum requirements in terms of greater than or less than? That's the minimum requirement. Means I can be larger, but I can't be below it, right? I can have more, but I need at least that. So what I'm going to think of this as food X and this food Y. You could use M and N, it's fine, but when I go to graph, it's easier for you to think of X and Y. So our first formula is going to be 16X plus 4Y has to be larger than or equal to 176. Okay, the next one is going to be 4X plus 4Y has to be larger than or equal to 56. And then that last one is going to be 4X plus 16Y has to be larger than or equal to 80. So these are my 3 formulas that I have, and I'm either going to have a bounded or unbounded region, and I need to graph these to see where those solutions would be. So I'm going to move up my little chart that helped me form my equations. Okay, and then I'm going to graph these. Another thing a lot of times this will say also is the X and Y have to be larger than 0, because you can't have 0 foods or negative foods. You have to actually feed people. You have to feed them nothing or some, right? You can't just have 0. So I'm going to go ahead and draw this as just our positive region. I'm going to go like this, just a little. Okay, there's my positive region. So if we look at this first equation, we could solve for y, or we could just put in points. Either way, I think the y-intercept and x-intercept are probably the easiest way to go. So let's call this one A, B, and C, just for me showing my work. So over here, I'm going to call this A, and I'm going to just do a little chart. I am showing a different way. Can you solve for y and do what we just did? Yes. But this way might be easier for some, so I want to make sure I give you a different option. So what I can do here is put in a 0 for x, and then solve for y. So what would I be left with is 4y. I'm actually going to show you a little bit different here. Do a little bit different chart. So what I'm going to do is put and this one is for 16x plus 4y equals 176. So we don't want to look at that greater than. We want to graph the line, and where the line is the equal. The greater than will come in for shading. So we're going to put the 0 here. So we would have just 4y equals 176. So we can divide by 4 and get a point on that graph. I don't know what that is. 176. Get my calculator out. Divided by 4 is 44. So there's a point. 0, 44. I need one more point, and I'm going to do that with my other intercept, is let the y be 0. So then I would have 16x, the y goes to 0, equals 176, and 176 divided by 16 is going to give me a pretty number as well, which is 11. So when I go to graph, I have 0, 44, and so 0, 44, maybe I'll count by tens here. So 10, 20, 30, 40. And this one's here's 50. So we're here at 44-ish. Okay. And then we have the point 11, 0. So if this is 10, then this is 20. 11 is going to be just a little past there. And this is a solid line because you're greater than or equal to. And we want to stop at the zeros. We don't want it to go beyond. So there's our first line. So then let's do that second section here, B. And we're going to do the same thing here. We're just going to make ourselves a little chart. And this time we're going to put in our zeros again. And I'm going to put in a 0 for x. So this one is with 4x plus 4y equals 56. And 0 for x would leave me 4y equals 56. And 56 divided by 4 is 14. Okay, for y, I'm going to let that be 0. So this one goes to 0, and I have 4x equals 56, which is also going to give me 14. So we have 0, 14, which would be about here, and 14, 0, which would be about here. And again, this is a solid line. We haven't really done the shading, but that's okay. They're all going to be greater. Okay, last one, section or graph C here is going to be almost the same as the first one. X, y, but this one is 4x plus 16y equals 80. And we're going to put the 0 in for x. So this will go to 0, and I have 16y equals 80. Okay, 80 divided by 16 is 5. Wow, these are really pretty numbers. It's awfully nice of them. And then the other way, 0 for y, that goes to 0. So I'd have 4x equals 80. And 80 divided by 4 is 20. So we have 20 here. So I have 0, 5 would be about right there. And 20, 0 is about there. And I'm going to draw the line between those. So even if I have 3, it's still where are all of them shaded? So typically, it's going to be above them all or the little triangle in between. Now, we want greater than everything. So greater than this line would have to be this side, right? Because that's going to include, if this continued, it'd include this part. So greater is this way for this one. Okay, greater for this one is also this way, above, shading above. Okay, and greater for this one is also this way. So where are they all? They're all going to be in this section right here. Okay, and that's our section. Not in the little triangle at all, just this and beyond. Is this section unbounded or is it bounded? It's unbounded because it's going up forever. Okay, we want people to have this much vitamins, iron, and calcium. You have to be in this section. Anything below, they're going to be missing one of those 3 key vitamins. Okay, all right, there's more videos that the book gives you, so hopefully this one will help enough for this one. So we did one harder one, one easier one, and you can use the intercepts like we did, or you can solve for y and use the slope and y-intercept. Both are perfectly fine.